Alright guys, we're going to go ahead and verify some trig identities today. And these are very important for pre-calculus and being able to manipulate sine, cosine, tangent. Now, if you remember Pythagorean Theorem, we have x squared plus y squared equals 1. Okay? And that's pretty normal. But remember, in trig, pre-calculus, we don't talk about x and y anymore. X-axis correlates with cosine squared, and with the y, it correlates with sine squared. Okay, and don't let the x fool you. It could be theta, it could be beta, it could be any variable in there. Okay, but it's always cosine and sine. So this is your first, and we call it the Pythagorean identity. Now from here, we can also derive others. If I go ahead and, I'll call this number 1. If I go ahead and divide everything by cosine, okay, divide by cosine squared, this becomes a 1. Sine over cosine is tangent, and 1 over cosine is, 1 over cosine is secant squared x. Okay, and this is the second identity that I should be able to know and solve and derive. And the last one, the third one, we're going to take the same thing. We're going to take my Pythagorean identity, and instead of dividing by cosine squared, we're going to divide by sine squared. Okay? And hopefully you remember that cosine over sine is cotangent. Okay? Sine over sine is 1. And 1 divided by sine squared is cosecant squared. And if you notice, cotangent goes with cosecant, the cocos, okay? You can think about it that way, the cocos. All right, so cotangent, cosecant, tangent goes with secant. And of course, we have our first one here, the Pythagorean identity. So I'm going to go ahead and use these two to go ahead and see if I can verify that this left side is going to equal to 2. Okay, that's what I want to know. I want to verify this is going to equal to 2. So what I do is I look at it very carefully and can see, okay, well, I have secant squared, I have tangent squared, and what I want to do is I want to change this. And if you notice here, I have secant squared x. And what I realize is that, okay, some of this is going to have to simplify in order so I can just be left with 2. And if I know my identities, you say I have 1 plus tangent squared, I have cotangent squared plus 1. And what you notice is if you secant squared x, I can rewrite that. Instead of writing secant squared x, what can I put? Okay, I can go ahead and put 1 plus tangent squared x. Okay, and that's going to cancel out the tangent squared. Instead of writing cosecant squared, what can I write? I can write cotangent squared x plus 1, and the cotangent squared simplifies. So that's what I'm going to go ahead and do. And this is just one method. So instead of cosecant squared x, I'm going to put cotangent squared x plus 1 plus, okay, instead of secant squared, I'm going to put what? 1 plus tangent squared x minus tangent squared x minus cotangent squared x, and I want to verify that that equals to 2. Now if you notice, cotangent minus cotangent squared simplifies. Tangent squared minus tangent squared simplifies. 1 plus 1 is 2. 2 equals 2. Boom. It checks out. All right. Let's go ahead and do one more. All right, guys, we're going to go ahead and do one more. And what you want to do is just verify that this left side becomes secant x. And normally when you see secant, cosecant, you want to change them into sine and cosine. Now, this guy here is by itself, so I'm just going to go ahead and leave them. I want to see if I can change the left side. So secant x, I'm going to go ahead and change them to 1 over cosine of x minus 1. Okay, that becomes a complex fraction, and that's okay. And that equals secant x. Okay, let's see if I can simplify this further. So what do you do here? Well, we have 1 over 1. We need the common denominator, which is going to be cosine of x times cosine of x. So this becomes 1 minus cosine of x divided by cosine of x. Now notice, these have the same denominator now. This has 1 minus cosine of x, so I can put that together. All over 1 minus cosine of x. Set that equal to secant x. All right, let's go ahead and see if we can simplify further. Since this is a complex fraction, I'm gonna go ahead and do my division algorithm. So I'm gonna keep the first one, minus cosine x over cosine x. Division becomes multiplication. And then what do you do with this guy? Well, you multiply by the reciprocal. So this is 1 minus cosine x. So what's the reciprocal of 1 minus cosine x? Well, it's 1 over 1 minus cosine x. Okay? So the other way you can think about it, if you want to put a 1 underneath. And what you're going to do, you're going to take this guy here, and all you're doing is the reciprocal. I know students like to call it the flip, but it's not correct. It's the reciprocal. So you just do 1 over cosine, 1 over 1 minus cosine. If you notice, let me go ahead and set it equal to 1 over, secant x. These guys can now simplify. You're left with 1 over cosine x. And guess what? That is secant x. Boom. So it works out. All right, thank you guys so much. I hope that helps, and look forward to making some more videos.